Whiskey 6 Alpha Hotel. This is episode number 96. Today, we're going to be talking about getting started with AREDN Mesh networking. I'm joined by my esteemed colleagues, David W0DHG, Dan NR6V, and Scott KM6RFB. Together, we are the WaveTalkers crew. So let's get started with today's Winlink check-in. So what I'll do is I'll jump over to that check-in. If you have access to Winlink, then go ahead and send us a Winlink check-in. Use use the standard Winlink check-in form. Send it to all four of our call signs. Those are W0DHG, NR6V, KM6RFB, W6AH, and our tactical address WaveTalkers. Just go ahead and separate each of those with a semicolon. When you use the Winlink form, we'll walk through that process here together in just a second. Down in the comments section, let us know, what is your experience with AREDN Mesh? Have you used it before? Have you not? Have you seen it used before? Let us know. We're kind of curious. And then go ahead and paste that comment into the comments, either on YouTube. And if you're joining us on YouTube, thanks a lot for doing that. And if you're here live in our Zoom audience, go ahead and post it into the chat there so everyone can see what your experience is. In the meantime, let's jump over to the walk-up machine and let's walk through that Winlink check-in process really quickly. So I've got Winlink up and running here. I'm going to come up here to the top of my toolbar and just click on the new message button. When that comes up near the top, you're going to click on the button that says select template. That's going to open up your template manager. You're going to go ahead and give that a click for the standard templates. Go down until you find the general form section. Open that up. Down here near the bottom, you'll find Winlink check-in.txt. Go ahead and give that a double click. If the demo gods are with you, it should open up in your web browser of choice. When it opens up, what you want to do is you want to come up here to the date and time field and just go ahead and give that a click. What that's going to do is it's going to open up a little pull down, and your date and time is going to set according to your computer's current date and time. Just go ahead and say okay for that. Then here's the to field. This is where you want to let us know all of our, or put in all of our call signs. Those are W0DHG, NR6V, KM6RFB, W6AH, and our tactical address, WaveTalkers. The from field is just your call sign. The station contact, that's your name or your handle. The initial operators, if you have anyone else watching the show with you, then go ahead and let us know what their call signs are as well, so we can get everybody checked in. For the session, this is going to be an exercise. Let us know the service that you're sending it in, either amateur radio or onto shares. Let us know the band that you're going to be sending it in. If you're sending it via the internet, then go ahead and just select Telnet. For the session type, let us know the mode that you're going to be sending that in. Here's the location section. You can go ahead and enter in a location. Your latitude and longitude should have the GPS coordinates all automatically set for you, either based on a built-in GPS or a connected GPS that you have, or the center of your grid square, whichever is connected. Down here in the comments section, this is where you want to let us know what your experience using AREDN Mesh has been. Go ahead and click the submit button. You'll get a couple of pop-ups. Just go ahead and keep clicking OK, and those go away after you click OK. Once you're back to a blank browser window, you can close your browser window. All that information should be entered into the Winlink message. Just go ahead and post that to your outbox here in the upper left corner. I'm going to close my window. You'll see an item listed as probably a number 1 here in your outbox, indicating you got one item. You can come up here to the open session type, click the drop down, select the type of session you're going to be sending your check-in in with. I'm going to select Telnet and then click the open session button. That should spring open a new window, and you're just going to hit the start button, and it should go through that process of sending and receiving any new messages. It looks like we have Winlink check-ins coming in from around the world. So later in the show, we will check back and we'll map all of those check-ins to see where everyone is coming in from. But in the meantime, let's jump back over to the slides and get into today's topic. So today we are going to be talking about the AREDN Mesh. And that instantly raises the question of, what is the AREDN Mesh? Well, if you just break it down, it's an acronym. It stands for Amateur Radio Emergency Data Network. So obviously we're talking about using data, high-speed data over the amateur radio bands. And it can be emergency data, it can be a variety of other different types of data. But that last part, the network, this is where things get really interesting for us. And this is something we're going to start diving into this topic just a little bit, because we need to review just a little bit of networking basics. So everybody starts off on a level playing field to understand both how cool this is, that what AREDN is able to do, and to kind of start to understand what you'll experience as you get into setting up the settings in there. So let's say you have a computer and you want to, I don't know, print something out. So you've got a printer. You connect that printer to your computer. You can use USB. That's pretty common these days. It could also be over a serial connection if you've got one of those old school printers. But you basically connect your computer to your device, whatever that happens to be. And that works great as long as it's just you with just one device. It works beautifully. But the second you add in another computer, so let's say you have other people living in the house with you, and they would also like to be able to print, or maybe you're at an EOC or you're at an event and you have other people who need to be able to print to that printer. Well, suddenly you've used up that USB port, and it gets a little awkward pretty quickly to have to constantly be switching that device around. So this is where you start reducing the amount of use on individual connections, and you switch over to some sort of a home network or a network type of setting. And you're going to use some sort of a network switch to be able to do that. We'll talk more about that in just a little while. But essentially what you're able to do is you're able to start adding additional devices onto this network, and then all of your devices can begin talking with each other. So your laptop can print to the printer as well as your desktop. Maybe you've got a mobile phone or a tablet that could also print, or maybe you need to access some files or something on your smartphone and on your smartwatch and so forth. All of that happens over your network, and everybody can talk and have a good time together. It works really well. But the challenge starts coming up when you want to start connecting to files over the internet. Now, this might be just simply websites, or maybe you're out and away from your home and you need to be able to get back into some resources that are inside of your home network. And that's where you start running into some of these challenges, because, you got to have some security on all of this stuff. So there's this concept or this thing called DNS. And really what this is it is a directory. It's like the old school phone book of the internet. And it knows where all of the different devices are located, what their address is. And the addresses are all these IP addresses. There are some of these that are publicly available. They're called DNS servers. So 8.8.8.8 is actually Google's DNS. And one of the things that it does is it translates that IP address, that four separated digits, into domain name. So for instance, if you wanted to go to smcm.edu, you would know that the DNS would know that 138.something.something.something belongs to that location. So that's the way that DNS is actually working. And it really is acting as a lookup table for all of the addresses and kind of a map of what's out on the internet. So it can direct your traffic from one location to another. So how do you get your traffic from your home network out to the rest of the internet? Well, you need an internet service provider. You got to pay the troll. You got to pay somebody to be able to get access onto the internet. And really, the internet service providers kind of break down into those that have a lot of infrastructure. So you're paying for access to their infrastructure. But to a large extent, what you're really paying for is these internet service providers have access to publicly routable IP addresses. And who knows what those publicly routable IP addresses are? Well, they're all inside of the DNS. The DNS servers all know what all of those different publicly routable IP addresses are, and it allows those addresses, it allows the traffic to move from one location to another. And these break into a variety of different classes, we'll call them, and it's numbers of IP addresses that you have access to. So when you sign up with your internet service provider, what are you really signing up for? Well, one thing you're really signing up for, is you're signing up to be able to have access to one of their IP addresses, one of their publicly routable IP addresses, and they assign that to your particular router so that any traffic coming from your home network getting out to the internet will make it back to your home and to the correct device. But you only get one of these usually, unless you pay a lot of money for multiples of these. So what do we end up doing? Well, there's this thing called a private network IP address space. So your router, your home network can use any of these different ranges of IPs. There's a Class C one, and this is probably the most common one that you're going to have assigned to your home network. And these are, you'll typically see that as 192.168.something.something. And that's a Class C address. There's also a Class B space and a Class A space. And these are private, meaning if you have this IP address and you're out on the internet, the other services out on the internet are not going to route that. They're not going to take that traffic and move it somewhere else. You have to have it translated into one of these publicly routable IP addresses in order to make all of that magic work in the background. So the fact that any of this stuff works is absolutely incredible. And it really does work really well, but it is very structured, but extremely flexible for being able to get every one of the billions of people on planet Earth with all of our multiple different devices all connected and able to talk with each other. But it does require a lot of structured data to be able to make all of that stuff work. So let's say you've got your house there, and one of the things on your home network that you're not allowed to do, and this is for, a really good thing, is you're not allowed to use the printer of your neighbor down the street. You can't just like jump onto their network or use your phone to be able to send something directly to them. You need to be able to go through the internet, do all the different security stuff that's out there. So all that's blocked. Basically, each network ends up being kind of an island with this one gateway that connects you out to the rest of the internet. So that brings the question of, so what is a mesh network? So a mesh network, in that sort of a setup, all of the different nodes, all of the different networks or services are all end up being peers. And so they can exchange information with each other directly. They're all routed essentially as if they're in one single network, which is kind of cool the way that it works. And these, when you add a new node onto the network, instantly what happens is that new node will start talking to all of the other nodes, and it will just figure out on its own kind of how all of this routing is supposed to take place. And all that's kind of hidden away from the user. We don't have to know all of the details of that. It just works. These are all, they still follow, the mesh network still follows your standard IP or internet protocol principles. So all of the normal stuff that you can do on the internet actually still works on a mesh network. Because remember, we're talking about the amateur radio emergency data network, then you're not allowed to do things that are outside of the amateur radio permissions, if you will. So you're not allowed to encrypt things, for instance, onto the mesh. So be very careful with what you're actually sending, because everything that you're sending over the mesh is completely in the clear. It's all not encrypted, if you will. So I mentioned those other private network address spaces. So AREDN uses the Class A private address space. Now, everyone could still, you could still use the private address space of the 10.0.0.0 network space at your own home, but because you're not connecting those two networks, it's okay. It's like everybody at their house has that 192.168 for the most part network. So AREDN Mesh has basically lots and lots and lots of different clients would be able to join onto this network, and the routing tables can support all of that. So connections between AREDN nodes, and when I say an AREDN node, I mean a computer, a device. It's you will see this a little bit as we kind of get into the demo. Any link can either be a wired link or it can be an RF or a wireless link. So it doesn't matter whether or not you've got a hardwired connection between two nodes or you've got a wireless connection between two nodes. And that becomes a really handy thing. Let's say you're at an event and you need to provide support for this event with your amateur radio team. You could have at the events at your EOC or at your net control station, you could have several different AREDN nodes all connected via hardwired together. They can point out their RF in various different directions. And then you could have wireless nodes that are set up outside of that area, and everybody would be able to talk and exchange information all at one time. Basically, in order to create a link, your nodes need to be able to see each other and they need to be able to talk to each other. So the seeing each other, that can be via hardwire or it can be wireless, and they need to be able to talk. They need to have a strong enough connection that you've got data that's being passed back and forth between those two nodes. And once you do that, it's magic. The link establishes very quickly, and suddenly the two machines and everything connected to those are able to talk. It's very, very cool. So let's say you're in a situation where you've got this really cool AREDN mesh network and you want to be able to get onto it, but you are way outside of the area. Maybe you're out at a remote location. Maybe there just aren't any mesh nodes that are in your area. So what are your options? Well, the first option is you can actually just get a couple of mesh nodes yourself and then create your own little mesh network. So your own network would literally look like this. You could have multiple different nodes set up. Maybe you've got a large property or you're setting up to support at an EOC and there's nothing else available. You can just you can put these nodes up and they will talk to each other, and it will just dynamically generate a network for you to be able to move traffic and information. But if you really want to be able to get into a specific net, then what you need to do is you need to make friends with somebody who has a network connection already on the mesh, and they've got a pretty good setup, and you can do what's called a tunnel. Now, a tunnel uses the internet to go from the tunnel server. We'll say this little house network here is the tunnel server, and this is the tunnel client. You would exchange some information back and forth. You would set this up ahead of time so you know how to be able to do this. And then your connection would actually go through the commercial internet, and it would be like a little IP-based tunnel that would go through the internet and connect over to the mesh. And so we'll show you what that looks like in a little while when I go through and kind of show the rest, do the demo of what this looks like. So you've got a lot of different options when it comes to making sure that you're able to get a mesh connection and set it up and be able to operate with it. So when we start talking about these mesh connections, there are really two primary locations that we're talking about. So we're all familiar, pretty much every device that you buy these days has Wi-Fi built into it. And Wi-Fi, for the most part, comes in two flavors. It comes in a 2.4 gigahertz flavor, and it comes in a 5 gigahertz flavor. Now, as hams, we tend to think of 2.4 gigahertz as the top end of our UHF band privileges. That's really the 12 centimeter band. And adjacent to where all of the public Wi-Fi, all the commercially available Wi-Fi is, there is a little sliver of amateur access that we have next to that. It's very, very close to it. In fact, it's just a couple of additional channels that we have access as hams to be able to use that. And so everything you're used to doing as far as Wi-Fi, so 2.4 gigahertz, it penetrates a little bit further into buildings, it can go a little bit further outside. All of the stuff that you know about RF automatically just kind of translates into being able to use that. The other one is the 5 gigahertz frequencies that are available commercially. And the 5 gigahertz frequencies are basically our 5 centimeter band privileges. And so we have access, again, to some very adjacent frequencies to what is commercially available. And we can do a little bit of overlap. You might remember that for our amateur radio license, one of the things that it gets us is we can drive more power. We can shift those frequencies into our band area. We still have to follow all of our rules as a ham, but there's a lot of capabilities that are in this zone. Now, when we start thinking about Wi-Fi, we start thinking about all of these different frequencies. One thing that comes to mind is that as hams, we're very used to working, say, on HF, and we have that VFO knob. It's really cool. We can choose wherever the heck we want to place our signals. We can have our conversations. You can see here in the waterfall, they might be evenly spaced. They might be not evenly spaced. There might be some large gaps that are set up in here. There might be tighter gaps in between other conversations that we have on HF. When the hams are the primary user on a particular range of frequencies, we have this ability to kind of just pick wherever the heck we want to be able to have our conversation. It's both a blessing and a curse. If you've ever tried to get on, say, 20 meters on a very busy contest weekend, and you'll see that there are signals just overlapping all over the place, and being able to find open frequencies and being able to find clear channels can be a real challenge. But as you see these lanes, when we start looking at some of the other different bands that we may be operating with, say in the Wi-Fi ranges, then what we're looking at is channeled content, because that is the convention that's being used elsewhere. And so being that we're secondary on those bands, we need to follow what those conventions are. So not only do we have access and privileges on the 2.4 and on the 5 gigahertz bands, but you'll also see that there's some additional privileges on the 900 megahertz band, as well as we did have some that were in the 3.4. That privilege has been sort of started to be pulled back a lot, and at some point we're going to completely lose that. But for right now, we're still able to use some of that. So these are the bands that AREDN is operating on: 900 megahertz, 2.4 gigahertz, 3.4, and the 5.8 gigahertz ranges. And these are all of the channels that are in here. Now, why are we talking about all this? When we get into looking at some of the mesh settings, some of this will make a little bit more sense. So just know that there are channels, and within those channels, there are also different bandwidths that you can use on specific channels so that you can send out your signal. So this is all just the rules of the road that we're trying to go over now. So those are the AREDN bands. It really is 33 centimeters, 12 centimeters, 9 centimeters, and 5 centimeters. Those are the ones that we've got. Now, what else is so cool about these public Wi-Fi access bands, if you will? Cheap, hackable gear. There is a plethora of cheap, hackable gear that is out there that already works with 2.4 and 5 gigahertz. And since our privileges as hams are very close. And by the way, when I say privileges, I mean, if you're a technician, if you're a general, if you're an extra, you have all of these same privileges. There really isn't much of a difference in the different levels. So as a technician, this is a great place to get in and really play with the Wi-Fi and the mesh stuff. So we got this cheap hackable gear. All right, what else do we have going on? So let's talk about what some of that gear looks like. So there's two basic types of gear, and we'll start off talking about the routers and the switches that are there. So these are your kind of typical home switches, and these have a bunch of Ethernet ports on them, and they allow you to create and talk to other computers on your LAN, your local area network. Basically, if you can have a hardwired connection into this switch, most switches allow you to share your information freely. It creates one single network between all of those. Now, some switches are called routers, and those switches will have a very specific port. Maybe they might have a couple of these, and those are able to connect to what's called a WAN port, or a wide area network. This is the internet. So if you've got your home router and maybe you've got a modem that connects via a cable modem, or you've got you're lucky enough to have a fiber connection into your house, or maybe you've got Starlink and you've got a satellite connection, that connection that goes out to your ISP is going to connect into your WAN port on your router. And the router has some additional brains to it, some additional logic that allows it to move the traffic and kind of tag it a little bit as it goes through. Now, another special thing that you can have on some switches is some switches have a PoE port, or multiple PoE ports. Now, what the heck is that? That is a power over Ethernet port. So when you have your router or your switch, you can have some ports that will supply not only the data that goes over some of the internal cables. And a couple of weeks ago, we stepped through the process of showing you how to crimp and set up Ethernet cables. And some of those pairs are used to transmit data, while other pairs can be used to supply power, either 24 or 48 volts of power to the remote device. Now, what would you do with this? Well, you could run additional devices by simply having them plugged into an Ethernet port or into an Ethernet cable. So you can do things like there are some phones that use power over Ethernet to power the entire device. There are some cameras that can be just literally hung out on a piece of Ethernet cable that is powered over the Ethernet. And of course, you can have wireless access points. And there are lots of other devices that are powered over Ethernet that we're just not going to go into, but that's kind of a high level of what those specific devices are able to do. Now, you also have, as another feature of your switches, some of these also have a Wi-Fi connection, or they have a access point built into them. So your one router switch is also a Wi-Fi access point, and then other devices can connect wirelessly to that. So that can be kind of this all-in-one device. As a matter of fact, I have one sitting right here. This is the MikroTik, and it's a router board, and you can see it's got a WAN port on the front. It also has some LAN ports on here, and it even has a power over Ethernet port plugged into here as well. And so this is actually a mesh node. We're going to look into the specific setup of that in just a little while. The other type of device that you'll likely run into with all of this low-cost mesh gear or low-cost networking gear are wireless access points. Now, some of these, as I mentioned, that this router that I have is also an access point, but some of these access points are just dedicated access points. They have they will put out a wireless signal. Clients can connect to them wirelessly. And for the most part, they really are a little mini wireless switch. They allow the creation of a LAN, and different connections can come into that switch, and you can share the information that's there. Many of these devices will have commercial 110 power or 220 power that you can plug into depending on where you are in the world, but others are powered over Ethernet, and they'll just have that power over Ethernet port. And so you can literally just plug the two devices in, and magically the power and the data comes through, it boots it up, and it configures it. Some of these ports even will get their configuration information from the router, from the switch itself. That gets into some advanced networking stuff, but this is what you're looking at here. It's basically a wireless switch. Now, it also has, because it's wireless, these also have antennas built into them as well. They have omnidirectional antennas, and as a ham, we would think of maybe a vertical off of your HT or maybe some other omnidirectional antenna that you may have. These are all, remember, this is commercial gear, so it's usually got nice housing around it and so forth, so you don't really see the antenna. Also, if you think about the bands that they are, a quarter wavelength on 3 centimeter band is a really small antenna. So they're really tiny, and they're built into the devices usually. You also have, these devices will have sometimes Yagis built into them. You can get those, and that allows you to have a little more directional signal to shoot a little bit more distance. And some of these will also be in a dish configuration for much longer distance throws that you may be trying to do. And so when I say longer distance throws, it's not uncommon to shoot a mesh connection 3, 5, 10, 25 miles and be able to make a connection over RF and have high-speed data that you can transmit from one location to another. So again, this is the bulk of what we're looking at, is the 2.4 and the 5 gigahertz gear is what we're looking at here. So with all of these devices, I mentioned these things were hackable. Now, what do we do? How do we get this from the devices that we either already have or that we're going to purchase, and then we get them onto being mesh nodes? Well, the first thing is that the manufacturer of that device has to essentially support the device being hackable. Now, they call it upgradable firmware. We call it hackable. We can go in and we can upgrade the firmware. And now, why would you want to upgrade the firmware? Well, first of all, you want to take over control of the device and you want to change some of the parameters that are in there, because by default, a normal commercial device will have things like encryption built into them. We're not allowed to do that on the ham band, so we've got to disable that sort of thing. Also, I mentioned that our frequencies are just a little bit adjacent to the public frequencies that are available. So we need to be able to take that firmware and use some of our ham technology and shift the frequency either up or down depending on the particular device and the band. So we need to be able to get access to the controls. So not every router, switch, Wi-Fi connection that's out there will you be able to use on as mesh gear, but the vast majority of them out there are able to have their firmware updated. So the second part of this equation is that it needs to be AREDN supported. And you can find a list of all of the gear that has already been upgraded on the AREDN website. So you can go to AREDN Mesh, and that's AREDN mesh.org. And right at the top, there's a link for where you can get all of the information. We'll actually look at that here. Let me come to, let me just go right here. And we'll switch over to this device. Let me show you AREDN Mesh. So this is what the AREDN website looks like when you go to it. And if you come here to the software drop-down menu, there's a link that says supported devices right here at the top. You can go ahead and click on that, and you can see all of the devices that have been tested that are here on the left-hand side. They're sorted by manufacturer. So Microtech is one of them. You come down a little bit further. Ubiquity gear is another really common one to be able to get access to. And there's a few others. So you can scroll down through the list, and in this list, it'll tell you whether or not this 5 or 2 tells you whether or not it's for 2.4 gigahertz or it's in the 5 gigahertz band. And it can give you some other information about the specific devices. So you want to come in and you want to check and make sure that the devices that you want to use on the mesh are available for you to be able to use. So once you've got that, you're going to flash the firmware, and there's instructions. Matter of fact, let me show you where that is as well. I'm going to scroll all the way up here to I'm going to go back to the main AREDN page. And under the docs section, right here at the very top, docs latest, go ahead and give that a click. And if you come down here, there is a downloading the AREDN firmware, and there's installing AREDN firmware. These two tutorials will walk you through the process of what you need to do to flash or to upgrade the firmware on your device. And sometimes it's a two-step process. Usually you have to flash the firmware so you can basically unlock the device, and then you need to load the AREDN firmware specifically onto that device and then be able to go through that. And these will walk you through that entire process. But it's different for each different manufacturer and each different device. And the AREDN team has done a great job of putting those instructions together. So I'm not going to walk through that process right now of going through and flashing the firmware. It's just it's too detailed to go through, and there's too many variations between different devices. But as a very high level, one of the things that you would end up doing is that you would take your particular device. So let's say I was going to try and flash this Microtech device, and it's brand new. I just took it out of the box, and I was going to make sure that to update the firmware. If you look on the front or somewhere on the device, you'll usually find a little tiny hole it's oftentimes close to the power cord. Sometimes it's hidden somewhere else. And it's a little hidden button that's in there. And so you get yourself a nice paper clip, you straighten it out, you press the button down as you plug in the power into it. And different devices have different specific steps that you would go through. And what that does is it basically resets the device to factory defaults, and it oftentimes will give you access to the upgrading the firmware. Sometimes you got to have another application to be able to do it. Sometimes you can get in and just do it through the command line to be able to do that. But that's kind of the high level of what those things look like. Let's go back over to the slides here. So once you've got your AREDN software configured up, you got the firmware flashed, you're ready to go. The next thing you want to do is you want to link these devices onto the mesh. And there's a variety of different ways that you can do that. As a matter of fact, let me go ahead and step through that real quick. Actually, let me go through a couple of more steps, and then we'll walk through some of the demos. Once you get your device connected onto the mesh, and remember, all it has to do is two nodes have to be able to see each other and have to be able to talk, and they will magically connect with each other. The last step, number 4, is either using or adding various services. Now, what am I talking about services? We'll look at some of these services that are out there, but any of the things that you can think about that you can do on the internet, oftentimes you can do some sort of version of that on the AREDN mesh. For instance, at your house, you might have security cameras set up, or at your business. Well, you can have security cameras, or you can have cameras that take their signal and they put it onto the mesh so that other people are able to see it, including you. These are super helpful for emergencies because you can actually put a camera in a location and then everyone can be able to monitor that. Let's say you put it on a mountaintop up at a repeater site and you've got a great vista, a great view of the area of the landscape. A forest fire breaks out, you're able to see exactly where that fire is coming. You're seeing the smoke, you can see what's going on from a distance, and anyone connected to the mesh would be able to see that. We'll look at an example of that in just a little while. Other things you can do, phones, IP-based phones and full PBXs. You can put web servers. You can put email Winlink clients and Winlink servers up there in order to be able to move traffic around. Video conferencing, chat messaging, all of those sorts of things can all be done through the mesh. So those are some of the services, and we'll see what some of those look like in a little while. Now, here is a critical piece of information for you. This is one you want to commit to memory, and it is the URL of your locally connected mesh node. And I'm going to show you what that looks like here in just a second, but it is local node :8080. So what this means is this is the domain name essentially for the local node, and :8080, this is the port that it's connecting to, because you're going to use just your standard web browser in order to connect it. Now, I would strongly suggest using either Chrome or Firefox for this. If you're a Mac user, and I'm a Mac user, you're not going to want to use Safari to be able to do this. There's too many security things that are built into it, and the Safari tends to have a difficult time finding the mesh nodes. It always wants to go out and search on the internet and try and figure out what's going on there. But Chrome and Firefox and Opera, and there's a whole bunch of other browsers that are out there. Those all work great with this. But commit this to memory: local node :8080. All right, let's jump over and have a look very quickly at what I've got going on here. So here is my mesh node, and I'm just going to connect onto this laptop here. So let me just connect over to this link here. So now you're just looking at that screen, and I'm just going to hit I'm just going to open a new browser tab, and I'm going to go directly to local node. You can see it comes right up because that's what I've been typing a lot lately: local node :8080. And what I have, before I hit return here, what I have out of the MikroTik router, I have my WAN port. So this is connected over to my internet connection because I'm actually using a tunnel to be able to make all this work. And then this is my LAN port. So this purple cable here, you can see, just goes and routes around my desk, and it comes over here into my computer. And that is what's plugged in right here at that point. Now, I don't have an internet connection on this machine at all. That's all I've got is just this mesh connection right here. So I'm just going to hit return, and we will see what comes up. So instantaneously, I'm getting a web page that is telling me about my W6AH Shack node. And I can see the location information that's here. I've gotten set up on Ham Shack Hotline, so I published my Ham Shack Hotline number. If people want to be able to give me a call with that, they're able to do that. Here's the mesh address and all of the channel information that this particular mesh node is connected on. I can go into the setup over here on the right-hand side. I'll click on setup. Now, I've already saved my password, so it knows what my password is for this. The default password that's set up into a mesh node that's published in the AREDN settings when you're going through doing your initial setup. Your setup here, this is kind of like your system settings or your control panel for your AREDN mesh node. And so it's got some real basic information. This is where you put the name of what your node is going to be called. You're always going to want to start that off with your call sign, and then do something really simple so it's easy to remember. So in my case, mine's W6AH-Shack. You've got the node description if you've got anything that you want to do there. Here's your mesh connection information. So if this was a node, we'll see what that looks like here in just a second, where it's going to be doing an RF link. Then this is where you would set the band that it's connected to. And notice you got, it knows what this particular device is that I've connected here. So it knows this can do both 2.5 or 2.4 and 5 gigahertz. A lot of the general information here is all automatically set for you. Basically, you can hit the default values and it pretty much sets everything up for you automatically. Here's the WAN connection. So it's saying, yeah, I would like to have this connected to the internet because I'm doing a tunnel, and I can be able to access this node and access the rest of the mesh right now. I'm doing it actually through the internet. Let's see what else is on here that you really need to know kind of right away. Down here in the optional settings, you want to go ahead and plug in your latitude and longitude. You can simply click the Find Me button, and it'll use some APIs and figure out where your location is, or you can plug it in a little more precisely if you would like. You can enter in your grid square, come down to the bottom and enter in your time zone and any NTP or network time servers that you're going to be using. Go ahead and plug all that information in, and then you want to just go ahead and save those changes. Another place where you've got some settings here, the port forwarding DHCP servers, very advanced. Don't need to worry about that initially. Tunnel server, again, very advanced. Once you get a little more experienced with that, if you have somebody who's been kind enough to share a tunnel connection with you, then the settings where you go and plug those in at is right here under that link. Administration is a place where you're likely going to need to go in and do a few things. You're going to come in here after you get your mesh node booted up for the first time. You've got an internet connection plugged into it. You're going to come down here to the download firmware section. Go ahead and hit the refresh button on that. And what it'll do is it'll actually go out, it'll use the internet through your connection, and it'll check and see what the latest firmware is available for your particular device. You just come down here, you can select the latest nightly build or whatever the latest build that you want to use. Go ahead and select it. Once you have it selected, you can hit download, and it will automatically download the firmware into your device, do the update, reboot the thing. It's all really hands off. It's super easy. You want to do this when you're back at your shack, when you've got a connection onto the internet, before you take any of this gear out into the field. Make sure you're all up to date with all of that. So that's kind of the basics of what it is to kind of administer this. There are some advanced configurations that you might need to go into. For instance, when I set up my MikroTik, I couldn't get my the power over Ethernet port to work. And you can come in here to the advanced configurations panel, and somewhere in this list, there is an option to be able to turn on the power over Ethernet connection now inside of this device. You just flip that switch, and then that device is then powered on, ready to go. So that's the kind of the administration side of kind of getting started with a node. Let me come all the way back out here onto the left-hand side over to node status. And here on node status, one of the other things that you've got is you've got a button here for the mesh status. So thus far we've only been looking at my node. We haven't gone anywhere else. Now, when I click on mesh status, what it's going to do is, because I'm set up on a tunnel, I'm connected onto the rest of the mesh. Here you can see it's refreshed, and it's got the node name for my particular node. And then down here, current neighbors. So these are the other mesh nodes that I'm in direct connections with in one way or another. So you can see that here's my tunnel that I've got set up. And then I've got this thing called previous neighbors. Now, previous neighbors, you can see it's got my call sign, W6AH-PMM5. So what the heck is W6AH-PMM5? So if I jump back over to my slides, which would be here, turn that off, my own slides. There we go. Outside of the house right now, I have a Ubiquiti PowerBeam M5. Now, this is a dish connection node. It's currently powered off right now, and there's just one Ethernet cable connected to it. You can see that Ethernet cable is running right here. I just went out and took this picture just a little while ago, and that Ethernet cable runs all the way here into my booth, and it terminates right here. So what I'm going to do is I'm going to go ahead and just take this cable, and I'm going to plug it into the power over Ethernet port right here on this little mesh node. And what it's going to do is it's going to send data and power from this little mesh node out to that connection. And in just a few minutes, it takes about a minute or so, sometimes a little longer, for this to boot up. While that's booting up, here, let me go back over to here. So oops, go back to there. So you can see it. So it's still saying previous neighbors. It hasn't booted up yet. And I will refresh this in just a little while, but I don't want to constantly be hitting the mesh node right now. So let's go ahead and look at some of these other nodes. You can see as I scroll down here, you can see the other remote nodes that are on the mesh, and it lists out what the name of those nodes are, the LAN host name for those, ETA. There's a bunch of other data that comes in here, but over on the right-hand side, this is super cool. Here's the services name. So on these different nodes, so for instance, on K6 CCC-HAP AC at home, there is a weather station. So I can go ahead and click on that weather station, and just that fast, it brings up the data that's being hosted by the weather station at that ham's location. It's being served out over a website. Notice it opened it up in a new tab for me. I can go ahead and close that, and I'm right back here into the mesh. And there are a lot. I mean, a lot of stations that are on the mesh node. And you may be wondering, like, okay, how big is this mesh? Like, how many stations are in there? How do I find that information? Well, if I go, I'll just open a new tab. I'll go back to the AREDN website. And right here at the top, there's a link for map, and you can click on map. And right here at the top, there's current known locations of AREDN nodes. You go ahead and click on that. And what it's going to do is it's going to bring up a map of all of those. And you can see there's little colors that's here. There's the 900 megahertz, 2.4, 3.4, and 5.8 gigahertz. And so right now it's populating all of those nodes. And there are literally nodes all over the world. I mean, they're everywhere. Australia, New Zealand, all over Asia, pretty much on planet Earth. AREDN is kind of pretty much everywhere. It's really awesome to see. One of the things that I like to do, since I'm working with my nodes and I've only got 5 gigahertz nodes that I've got here, so I can come over here to the layers, and I can click on layers, and I can turn off the 900 megahertz, the 2.4, and the 3 gigahertz. And now I'm only looking at the nodes that are the 5 gigahertz nodes. So these are the ones that I likely would be able to connect with. And you can zoom in to these. You can click on them, and that tells you information about them. If you're connected to the node, to the mesh, you can actually look up that node's console and jump over to it. So a really fun thing to be able to get in and play around with in there. Let me go back over to my node, and I want to show you a couple of things that you can do with this. So first of all, I'm going to come up. Let's see if that node booted, by the way. Let me hit refresh, and let's see if it's appeared yet. It should have. Yep, there it is. So now we can see there's an active, this node is now booted up. So again, that's booted up off of this Ethernet cable. It's getting its power directly from this, and it's going out to that dish, and we'll go into that and see what that looks like. So in order to jump over to another node, you can simply just click on the link for it, and it magically transmogrifies you over to that other node. So you can get in, and now if I know, for instance, what the administrator password is on this one, I can click on setup. I can enter that information in here, and I can get in and I can configure this particular node. Now notice this one is my W6AH-PM for Power Beam M5-1, and I've got all of the settings that are set up here. Notice I'm set up on channel 173 at a 10 megahertz bandwidth, and I've got the power settings and so forth here. All the rest of the stuff that I showed you before all still works in here. I'm going to go back to the node status. And what I want to do is I want to come over here and show you something else before we kind of dive in, because I want to show a couple little other things about this demo. One of which is this signal to noise SNR charts link. If you go ahead and click on that, what this is going to do, and I'm going to go ahead and turn the sound on this. And if the demo gods are with me, then all of this should go out over the internet connection as well. Let me make sure I'm not going to get make sure all that's going to go through. So hopefully that'll go through to when we get this up. So this is just sitting here. We're going to come back to what this page is, but what this is doing is it's looking at the dish that's outside, and it's looking at any looking for any RF signals that it can hear. So I have another mesh node here. So let me switch over to my overhead cam here. So this is a Ubiquiti. This is a NanoStation. It's a NanoStation M5, and it's the XW model. And I've already got this all set up for AREDN. On the bottom of these stations, there's two ports on the bottom. There's one that is the main port, and this is a powered over Ethernet port. And I'm going to show you plugging that in just a second. There's also a second port, and so you can daisy chain these. So maybe you've got in your EOC, you've got several of mesh nodes, something like this. You could have several of them daisy chained together, and so you could put them as sector antennas maybe, and kind of spread your signal out in a particular area. That's all set up. You can see that the node is currently powered off, and this connection, what I'm going to do is I'm going to actually this is going to be its own little island. It's not going to be connected to my other, to my router. It's not going to be connected to anything physically, except for I do need to power this on. So I have, in order to do that, I have a little PoE injector. So this is just a little tiny device, and all it does is takes power that's plugged into the wall. And I've got a LAN cable if I do need to plug that into my laptop. That's ready to go, but I can even unplug that for right now. And this is the PoE injector port, and it just says PoE on it. So I'm just going to take this cable, which is the other end that plugs into here. When I plug it in, we should see the little lights that are coming on right here into the mesh node. So this thing is booting up. It's powering on at this time. I'm just going to kind of sit the thing kind of up on the side of my desk here for just a second. It's a little bit out of view, but I'm going to come back over to this while I'm talking about it. So now what we're looking at again is we're looking at the dish that's out there. And as soon as this node finishes booting up, it's configured to be on the same channel, the same frequency, the same bandwidth. It's configured for all of that. And we should start seeing a little signal that's coming in via RF as soon as it finishes booting up. And then we'll know that that node has come on and that we have a connection to it. And I want to show you how you would use this pointing, because one of the things that's really critical when you're doing these AREDN mesh nodes, we've got some sound coming in. So very high frequency. All right, so as I hold this up, you can see the signal level kind of rises a little bit right here. If I hold it down and use this ugly bag of mostly water to block the signal, you can see that the signal level itself kind of drops down right in here. As soon as I bring it back up, so it's pointing towards, because I've got this signal to noise ratio, I've got the sound turned on, and actually go ahead and turn that off because I know that's a little annoying to be able to listen to. What this is doing is it's showing me the signal level. And so this is how you can go through and you can start to point to the dish or point the various different nodes. As you're pointing them around to another node that you might be able to see, you can go into this screen and you can start to see where your signal levels are good or bad. So if you need to maybe adjust the angle or the tilt or the direction that you're trying to point in order to make that connection. So your two nodes are able to see each other, and you want to optimize your signal so that you can really get the connection as strong as possible. Now, here in the booth, I literally just have a couple of walls between me and the dish, and I've turned the power down on both of these, so it's not super high. But I'm just going to sit the dish, the node over there to the side. When you're in this screen, one of the things you're able to do is you're able to click the. Let's see. We're just going to click on the quit button right here. And that's going to take us back out to our main mesh connection. So I'm going to go now. Again, we're on the dish that's outside, and I'm going to go ahead and click mesh status at this point. And if the demo gods are with me, we should see, there we go. Current neighbors, it's got my W6AH NSM, which is the NanoStation M5 XW-1. So that node is now connected to the node that's out there. The one that's outside is connected into here. So this is connecting out to actually to the internet over the WAN port. My laptop is plugged in here into the LAN port. So that's how we're seeing all of this in here. And then on the power over Ethernet, that's connected to the power beam outside. And then this nano station right here has its connection directly via RF from the unit that's outside. So let's go into that node from here. I'm just going to go ahead and click on the nano station M5. And if the demo gods continue to be with me here, we should see, hopefully I don't have to repoint this thing. There we go. We should see that we are now on the nano station here. Let me switch over to it so you can see it up a little closer. Here we are now on that node completely wirelessly, and other people who are on the mesh would actually be able to do all of this kind of traversing around and be able to get all the way into that node to be able to access some service maybe that was running on it, or use some sort of a connection that was over there. So, but I can get in here, and now again, remember, we're on this node that's not physically connected to anything. I can go to the mesh status. And again, if the demo gods are with me, we should see, there we go. We can see the current neighbors. That's that power beam M5 out there. And then the remote node. So these are all nodes that are outside. And notice it's actually going through the tunnel. It's letting you know that these are going through the tunnel. And we can see all of this information. Now, what's something that would be kind of cool to do? So we're inside of our web browser. And this is actually really important because you can do anything you can do inside of your web browser, you can do inside of here. So I'm going to press Control F, which is just the find function on my browser. And I've typed in a call sign here, W6BI. This is Orv. He is the AREDN Mesh guy. Pretty much anytime you see anything with AREDN Mesh, Orv is pretty much doing the demo. So I've just searched for his call sign in this list of all of these all the text that's on this page. So I'm just going to use the down arrow here, and so it's just using the search feature in the browser, and I'm going to click down a couple of times because what I'm looking for is Orb's shack node. So W6BI-shack-node. So that's the node that I'm looking for. And over here on the right hand side, we can see W6BI-SoCal-webcam. So I'm going to go ahead and click on that. Now I'm out a remote location. I am on a wireless node that's connected to other mesh connected systems, and I can go in, I can look in real time at the mountaintops around here. This is Camarillo Hills. This is here on the top of South Mountain. There's another one. It's pretty foggy out there today. Here we can see that, and you can see the time. This is an older shot here. Some of these are fully updated, others are not live. This one's a live shot to 218 at 13:45, and these are all snapshots of these. Let's come on down a little bit further. Here's the Central Coast amateur radio cameras. So this is up in San Luis Obispo. This is a live camera that's up in San Luis Obispo. I'm down in Ventura. It's traversing the AREDN Mesh network in order to get this image to come up here. Now, how cool is this? When the Thomas fire broke out, when the Woolsey fire broke out, the first reports, the first visual images of those fires were actually sent in via these mesh cams coming over AREDN Mesh. And they were actually, many of the EOCs here in Ventura County all have mesh nodes connected to them. So they're able to literally stream real-time information, real-time video, real-time images of incidents that are going on directly into the Emergency Operations Center, all using this wireless high-speed data network that's been set up. It's absolutely just incredible. So that's kind of a quick look at some of these features that are created in here. They're, as you look through the different services here, so here's a mesh chat, Winlink post office. There are a ton of services that are on there. So what else can you do with these? Well, if we go back to the AREDN website, AREDNmesh.org, and we come over here to the docs section again, look at the latest docs that's on there, and we scroll down just a little bit once it loads up. There we go. We scroll down, and here's all that setup stuff I was talking about, network design guide. So if you're curious how to set up a microwave network, some of the networking principles, there's a ton of information that's already on here as well. But this is what I find super exciting, this applications and services guide. These are some of the services that you can set up and run on AREDN, and many of these are all open source programs. So for instance, we'll click on the chat programs, there are a bunch of online chat services that you can usually, and what you do is you download the source code for that, you install it on your, say, your Mac, your PC, your Linux box, your Raspberry Pi, and that's connected into your mesh node, and then you serve those services then out to the rest of the mesh to allow other people to be able to use them. And there's a lot of these, there's a lot of step-by-step guides that are in here, kind of high-level overviews that you're able to go in and see. I'm going to come back up and go to, there's email programs that are on here, file sharing, voice over IP, and video conferencing services. So if you're here live in the Zoom, hey, thanks a lot for joining us live in the Zoom. There are similar sorts of things that you're able to do. There's PBXs, there's phone systems that you're able to use and do direct calling over the mesh. There's video services, voice over IP, that you can use soft phones so that you can link your, because your wireless router, remember, can create a local wireless network. You can have other devices in your area that can then, in your localized area, can connect via Wi-Fi, because your phone already has Wi-Fi, can connect onto this mesh node, and then you can use things like voice over IP phones directly onto that and talk to other users on the mesh with it. Let me come up and look at a few others. Video streaming and surveillance. So if you're looking at being able to put on video streaming from a camera, all of that information is up here as well for you to be able to go in. Network management tools. This is one that I have found really interesting. This is computer-aided dispatch, and there's two main programs that are available on here. One called EmComm Map, and the other one is OpenISES Tickets. And this is a full ticketing system for being able to dispatch resources during an emergency. It looks like it's being used by some emergency services in some locations around the world, but it can certainly be used by hams to be able to help map out and track events that are going on as well. There's a ton of information of other resources that you can get in, and you can start to plug a lot of this information in on your mesh node. So let's see, what else do we have? Other things that I have found as I've been getting into this a lot more to be helpful. Certainly being able to go on to the AREDN website and download. I showed you the map. Let me back up a few steps. Let me just go back to the AREDN site. I showed you the map that you can download, the one map that's here, but there's also locations of super nodes. I didn't go into kind of what super nodes are, but here you can get a map of where those are and how to be able to connect to those. You can also download the KML files of all known nodes, and you can download them also via just the different frequencies that they operate on. Now, as hams, we have a lot more frequency in the super high frequency range and up, and the VHF range. But again, what AREDN is really focused on is the ones that are adjacent to commercial frequencies. So that gear that's readily hackable is available. And so these are the KML files that you could download. You could plug this into Google Drive, or plug this into Google Earth, or into your own mapping system, so you have access to all of the information even when you're offline. Let's see, what else do we need to kind of cover? I think that gives you kind of a high level of what this is. As you're trying to point your dishes, one of the things that you may want to check out is a program called Radio Mobile Online. You can get to that. It's at Victor Echo 2 Delta Bravo Echo.com. And when you go on to Radio Echo, you set up a free account to be able to go in there. You plug in some information about the various different locations of your different sites that you're trying to connect with. And then there's a way to do line of sight calculations. And so you can see the Fresnel effect, and you can see the line of sight. So this would be, say, if I'm trying to shoot from my location here, and I'm trying to shoot to a particular other location, it'll actually calculate all of the terrain, what the heights all need to be in order to get that connection. I can see here I don't have a good connection here because of where the tower height, there's a piece of land that's in between me. Here's another calculation that is, I went through and I tried to figure out, like, okay, how tall would the tower have to be for me to be able to make that connection? Well, it turns out it would have to be about 300 feet tall in order for me to make that connection. But it tells you a lot of information about about your overall connection. It'll show you mapping between the different locations. And as you go through, you can start to connect up to, so this is going from my shack to another node that I was able to get a solid RF connection to that is at another location. It's down lower than I am. I'm up on the hill and so forth. So again, this is VE2 BDE DBE.com, and that's the website for that. It's called Radio Mobile. Great little site that you can get in and use. And yeah, I think that kind of covers the basics. That gets us to the end of the hour. Let's see, is there anything that I missed, guys, for that quick initial walkthrough of the AREDN stuff?
I think you covered it pretty well. There's so much, but you've given it a good overview.
Excellent. All right. Let me jump over to my walk-up machine. So this is back to my Winlink. And actually, I'm going to probably need to check this a couple of times because I've been talking the whole time. So it does look like there are quite a few check-ins that have been coming in. If you have not had a chance to send in your Winlink check-in, go ahead and do so. If you're watching this on YouTube later in the week, you're not watching it live, please go ahead and send in a Winlink check-in. Let us know what you think. If you are watching it live on YouTube or time shifted, please consider liking the video and subscribing if you're not already. Also, leave us a comment. Let us know if you found this information helpful. So we can consider what additional shows we're going to do related to this topic. So I'm just going to keep checking a few times, make sure we've gotten all of the Winlink check-ins downloaded. It looks like we've gotten quite a few. So now what I'm going to do is I'm just going to come over here and I'm going to click on the map icon here in my Winlink. I'm going to click the drop down here. This is select from. So because I've received all of these Winlink check-ins via the form, all of those are mappable. And so we're going to actually map all of those check-ins that we've got. If you would like to see how this would work for your own Winlink setup, just go ahead and select the messages icon, messages option, and that will map out all of the received Winlink messages that you've received, not necessarily the ones just for the forms. All of these other items listed here are for other forms that I have received into my account. So I'm going to come down and select the Winlink check-in V5, and I'm going to hit the display map icon button. I'll just zoom, I'll blow that out to full screen. And then I'm going to zoom out to get a full view of planet Earth, and we'll see where some of the check-ins are coming in from. It looks like we've got Bill joining us from Hawaii, Kilo Hotel 6 uniform. Thanks a lot. Aloha to you, Bill. And it looks like we've got Terry down in New Zealand at Z1HOG. We also have Victor Kilo 2, Sierra Kilo Yankee joining us from Australia. Sydney, good morning to you there. And up here, we've got Franz joining us, and looks like Roland joining us from Austria and Germany, respectively. Let's zoom in a little bit more, and we'll zoom back into North America. We'll zoom over to that location. I do have some filters running, so some of these stations are checking in, I believe, via HF. Yeah, these are checking in via HF at these different locations. So the mapping is going ahead and filtering those. It looks like Logan probably is over here, also is checked in via HF. We've got Victor Echo 3 Yankee X-Ray up there in Canada joining us. And we'll run over these other stations here so other folks are able to see that we did get all of your Winlink check-ins. And so if you're not seeing your name, but you did send in your Winlink check-in live during the show, it may be the case that you're using an old version of the form. So be sure you are running the latest version of Winlink and you've updated your forms. It's real easy to update your copy of Winlink by simply quitting Winlink, launching it again, and you will be prompted if you have if there's an update for you. So let me make sure I think I missed a couple over in this area. Maybe I missed a few down here. I'm not sure. There we go. Got some folks up here in that area joining us up here in the Wisconsin area. Roll over all these, make sure everybody's able to see that we did get their check-ins. And let me go ahead and zoom into the Pacific Northwest a little bit. There we are. Some of the stations up in here that have gotten their check-ins. Good to see everybody joining us here today. Quite a few up in the Sacramento area. Their check-ins. Here in Nevada, a couple of down here in Vegas. Always great to see the connections coming in from all over. Let me zoom in a little further into Southern California. We typically have quite a few folks joining us from our local area down here. And great to see everybody there. There we go. Perfect. Excellent. So let me jump back out. We'll bring the guys back up and we'll go back into the booth. There we are. And looks like the guys are coming back up. Perfect. Dan, any closing thoughts from you for this week?
No, well, yes. AREDN is really fun. I was really into it for a while, and my dish got blown off axis, and I just haven't made it up on the roof to re-aim it. A lot of new stuff in the firmware. They've made it much more flexible, much easier to upgrade your nodes, and a lot of built-in quality improvement algorithms. So yeah, it's fun and growing, and I want to get back. You got me interested again, and I'm got to get back into it. Get up on the roof, get that aimed, so I can get back on.
You know, one of the common jokes for amateur radios is that it's pretty good for amateurs, and I think the AREDN software is absolutely amazing. It's pro level for sure. The team and the folks that have been contributing to the AREDN mesh and all the software to be able to develop it and get all this stuff up and running is absolutely incredible. David, W0DHG, what kind of closing thoughts do you have for us this week?
So it was an amazing overview. Scratch the surface of what it takes to get set up, what the gear looks like. Much like Winlink, when we started our Winlink series, we talk about how the tool works, what it looks like, how to get it set up. The power of this is getting into what you see on the mesh and connecting into things like you showed the weather station. You showed some cameras. There are chat features, phone connections. There are file storage servers. Lots of stuff that you can do. In the future episodes, we'll dig in a little bit more about once your mesh is up and running, what you can do with it, what the tools are that are there, and how you can use it. We've used it in the field for races to put cameras up, to relay messages back and forth around large mountains and distances. So there is a lot you can do, and this is just a great start for what I hope will be a fun AREDN series.
Excellent. Scott, KM6 RFB, what kind of closing thoughts do you have for us this week?
Again, great presentation. And actually, a lot of this stuff has helped me to get some of my gear squared away. That I was missing a couple links to how to do something, and I was able to get it done. And in one of my CommT kit, I've got it's an iGel little USB AREDN stick that I can hook into the side of my laptop if I'm out in an area that I can get into an AREDN network. So that's a nice little portable device. And I will add that we are looking at it from a public safety standpoint. We view this as a very interesting backbone because we have a lot of local area hospitals up where I'm at. And from a public safety standpoint, if the internet goes down, if I can get the hospitals to install an AREDN dish on their hospital, we can utilize that to do bed polling. We can utilize it to find out what their status is. So basically, whatever the internet can do, AREDN can do, and provide us a means of emergency communication with our local area hospitals. And I've talked to some of our local area hospitals, and they're interested in it. And in the Sacramento region, we've got a group that is actually actively putting dishes up on different buildings and different mountaintops to build this infrastructure. So it's interesting. Some of the issues that we do have to look at is some of the hospital equipment uses some of the same frequencies as AREDN does. So we have to figure out, are we creating an interference with them if we put something on top of their hospital? So it requires us to work with their folks to see what we can do.
Excellent. Thanks a lot for that, Scott. Yeah, I'm really excited to be able to get in and do some more playing with AREDN, play with the different nodes that are out there, connect to them, explore what's out there. There's just not enough hours in the day right now to be able to get in and explore all of the different pieces that are out there. So I really encourage you to get some of this equipment, to be able to set it up. We'll put some links on WaveTalkers, and we'll link it down in the description with some of the common tools that we're all using to be able to get onto the mesh. And again, if you can get into the main mesh, it's great. If not, just being able to create your own little mini ad hoc network of different nodes and to be able to support the events, support the EOC, the hospitals in your area, and so forth is absolutely incredible. If you find the stuff that we're doing really helpful, consider going on to wavetalkers.com and use that buy us a coffee link, because it really does help keep the lights on here and keep us being able to afford to kind of keep pushing out all of this equipment and these shows on a regular basis. So it really helps for all of that. So with that, we'll say 7-3. By the way, next week, I'm going to be supporting the Ventura Marathon. And so check your email as to whether or not we're going to do a formal show. We'll probably do a little walkthrough, if nothing else, via our Zoom. If you're here inside of the Zoom, hang around for the after party. If you would ever like to join us for the after party, just go on to wavetalkers.com. At the bottom of every page is a join us link. Sign up. We only send out one email a week, and we give you the link for what the Zoom is going to be. And then you're able to join us for the after party. And when we unmute the mics and everybody's able to talk and ask questions. So we'll say 7-3, and we'll see you guys next week or the week after that. There we go.